This is the Tree of Life, Season 26, Chapter 8. In this episode, we will be defining what structures are in light of our discussion of Fermat's and Maupertuis principle based upon the 1924 doctoral thesis of physicist Louis de Broglie and applying it to sequential substitution events. In 1924, famous physicist Louis de Broglie published his doctoral thesis. The Fermat principle applied to the phase wave is identical to the Maupertuis principle applied to the moving entity. This doctoral thesis provides a clear explanation for what these structures are that we have been writing about throughout the podcast: how to create a glitch in the matrix. In fact, I will define them in the terms suggested by de Broglie, namely, that they are four-dimensional physical structures where nomological information can be encoded. The necessity of these structures is demonstrated by what we observe about the guiding of subjects outside infinite recursion by the paths or trajectories of the subjects inside those trajectories. That is, there is a law-like feature of the universe. Once one accepts interaction ruling between several systems might be encoded in a physical underlying structure. To quote de Broglie, non-locality would follow from the necessity that each corpuscle, a constituent particle, a photon, involved in an interaction, must be informed about all its possible behaviors in relation to all remaining possible behaviors of all other corpuscles. This is what we see when infinite recursion produces a certain set of interactions, which appear to influence the behavior of all other subjects outside it. Likewise, de Broglie also noted this guiding behavior as a product of the phase wave of the corpuscle distinct from the corpuscle itself. In that, there is some quantum potential to the phase wave independent of the corpuscle. Now, if you imagine that instead of light, or photons, we are talking about the waveform which represents a class of subjects. And you imagine that in reverse substitution, with integration, we see no creation of an analog structure. And in negation or lack of integration, we see decoherence, with the particle, the subject, falling into infinite recursion, distinct from the phase wave. We can see that Fermat's principle, which aptly describes time parsimony, is equivalent to the Maupertuis principle governing path parsimony within that recursive first path. We can also see that the manifold structures of infinite recursion, one for each convoluted descending path, only exist because of the decoherence represented by negation at the end of reverse substitution. But the waveform or phase wave and the particle, the subject, are only temporarily separated by the decoherence, which, through measurement reversal or acquiescence at the conclusion of the substitution event, shake hands. Thus, the trajectories of the particle, the subject, within infinite recursion, inform the phase wave beyond time parsimony outside the bubble universe. From this, we see that de Broglie's 1924 doctoral thesis supplies a ready explanation for the structures of this podcast, as four-dimensional structures where nomological information can be encoded. That's the end of the podcast for today.